Okay, students, this is going to help you prepare for graphing inequalities in two variables. So the first step is to make sure that you are in slope-intercept form. So just as a reminder, y equals mx plus b. The b is your y-intercept, and the m is your slope, or your rate of change. And this is also rise over run. Okay, so let's go ahead and get started. This inequality is already in that form, so we can actually go straight away to our graph. And let's do the x-axis here. So we have our x and our y-axis. We're going to go ahead and start at our y-intercept, which is 1, 2, 3. Okay, now the slope is telling us to go down 1 and right 2. So we'll go ahead and do a few points like that. The next thing to consider is, will this be a solid or a dashed line? If we have a less than or greater than, we have a dashed line. Less than equal, greater than equal will be solid. And of course, if we have an equation like we used to have, that's always solid. So this one, since I have a less than symbol, and I shouldn't put the line there because now it looks like equal to, we're going to go ahead and dash our line. We'll put arrows on both ends to show that it's going to continue. And now we're going to pick a test point. So I usually like to test 0, 0. You may always use this if the line does not intersect 0, 0. So I'm going to use my original inequality right here, and I'm going to test 0, 0. So I put a 0 in for y, I put a 0 in for x, and I get 0 is less than 0 plus 3, 0 is less than 3. That is a true statement. That means wherever I tested the point, if it's true, that is where I'm going to go ahead and shade. And this half of the plane contains all possible solutions. Nothing on the line itself because it is dashed, but everything to the left and below of that line is a solution. Okay, for the second question, this one is not in slope-intercept form, so we're going to have to do a little bit of work here to get the y alone. So we want to isolate y. Now you can still do your do and undo steps if you want. What was done to the y first, multiply by a -2, and then added 4. We don't care about the other side of the inequality. We just want to know what happened on the side with the y that I'm trying to solve for. To undo, we're going to subtract 4 and we'll divide by a -2. So let's go ahead and solve for y. So I'm just going to rewrite this here. And I definitely encourage you to pause and try some of these steps to make sure you're comfortable. 4 take away 4 is 0, so I'm left with a -2y is less than or equal to 6x take away 4. The next step says to divide by -2. Now here I want you to be very careful. Remember with inequalities, if we divide or multiply both sides by a negative, what happens to that inequality? It's going to reverse. So it's going to be greater than or equal to. Now this is our math is love where we split the fraction. 6x over a -2 is -3x. -4 over -2 is +2. And now we're ready to go ahead and graph. So let's go ahead and get some axes down, our coordinate plane here. Okay, we're going to start up at 2. That's our y-intercept. The slope is -3 over 1. We'll go down 3, right 1. And we can do another one. And this is a solid line because we have a greater than equal to. Put arrows on both ends to show it goes on forever. And now we do our test. So again, I'm going to use that 0, 0 as my test point. If it's true, I shade where the test point is. If it's false, I shade the other half. So let's go ahead. I'm going to plug it into my original. So I'm going to do my test up here. So I'm going to say 4 minus 2 times 0 is less than or equal to 6 times 0. So 4 take away 0 is just 4, and it says 4 is less than or equal to 0, and that is false. So since that's false, I don't want to test on this side. I mean, excuse me, I don't want to shade on that side. I want to shade on the other half, and that's where my solution is.